This is going to be section 12-2. We're going to be solving quadratic functions. And so today you guys are going to solve quadratic equations by factoring, solve quadratic equations by the square roots method, solve quadratic equations by completing the square, and solve quadratic equations by the quadratic formula. And then lastly, we're going to take a look at an element of that quadratic formula called the discriminant and interpret what that means. Now, all of these different things you have been taught before in your previous math classes, so this is almost like it's a review. I'm just touching little by little on each of these elements as like a refresher of, oh yeah, remember, we can do this. The first we're going to talk about is the principle of the zero product. The idea here is if I have two numbers being multiplied together and a equals 0, I can assume that a equals 0 or b equals 0. And likewise, if I know that a is 0 or b is 0, then I can assume that if I multiply these together, it's also going to give me 0. This analysis allows me to be able to solve equations by factoring. So in this first example here, we'll look at that zero product. Well, if I take this 2x squared minus x equals 3, if I subtract 3 on both sides, then I'm going to get this 2x squared minus x minus 3 equals 0. Then that factor by grouping method, so the 2 times negative 3, that gives me negative 6. And then I list all the factors, and I find that this combo of 2 and 3, if I do negative 3 and positive 2, that's going to be the values that give me this middle number, negative 1. So I break up this negative x into that negative 3x and that 2x. Then the rest is factor by grouping. So if I factor this side, there's an x in common. If I factor this side, there's a 1 in common. And so now rewriting the same, whatever's in front goes in the next one. And then now that we're here, I can set each of these, set them equal to 0 and solve. So if I say 2x minus 3 equals 0 and I solve for that, add 3, divide by 2, that's why I got x equals 3 halves. And then this x plus 1 equals 0, that's saying x plus 1 equals 0, minus 1 on both sides, and that's how I get my x equals negative 1. So just know that we're able to solve by factoring. Now the next is going to be the square roots method, and the way that we solve for this is typically when you only have some sort of x squared term. And if it's already in this form, then you just want to isolate the x squared term and solve for x. So I can add 10 to both sides, and then divide both sides by 2. And then now that my x squared term is by itself, I can take the square root to both sides, and I'm going to get x equals plus or minus root 5. And so that's going to be my solution there. Now I talked a lot about this idea of solutions and what does it actually mean when you find a real solution. So if I were to solve this equation here, f of x equals x squared plus 8x plus 15, when I solve it, I did it by factoring. So x is negative 3, x is negative 5. Notice that's where it crosses the x-axis at negative 5 and negative 3. When we are trying to find solutions by saying this equals 0, what I'm trying to say is where is it going to cross this equation of y equals 0? And so it's going to cross this equation of y equals 0 at negative 3 and at negative 5. And so it's going to cross the x-axis. And I could label them as zeros, or I can label them as those x-intercepts that we've already talked about. Now another method to be able to find the exact zeros of the solution is going to be by completing the square. Now the way that we do this is we set whatever our equation is to equal 0, so I set this equal to 0. And then I want to get rid of this c, so I'm going to add and subtract it to either side. So in this case, to get rid of it, I have to add 10 to both sides. If I have an a here, you want to divide by this a. In this case, there's no a to divide by, so I don't need to worry about that. And so now I'm going to do this thing called completing the square, which is why we call it completing the square. To complete the square, you take the b divided by 2 and square it. And you take that number and you add it to both sides. So this b, this negative 6, I divided it by 2, that's how I got negative 3, and I squared it, and I get 9. I need to take that 9, and I need to add it to both sides. Now the reason why I do that is because this portion here will factor, and it will always factor into a perfect binomial. If I wanted to do that off to the side here, I could do a times c I get 9, and then 3 and 3, that gives me the -6. They're both negative. And so I get x minus 3, x minus 3. And so that's going to become x minus 3 squared since I have two of them. So that's just something to be aware of, is that they will always factor. That's why I want to complete the square. And so now it's in this binomial form, I can solve for my x. I can get x by itself. And I can do that by taking the square root to both sides. And so I just rewrote it here. So taking the square root to both sides. And now I get plus or minus root 19 equals x minus 3. Then if I add 3 to both sides, I'm going to get x equals 3 plus or minus root 19. This right here is my solution. So the first thing I did here is I set the problem equal to 0, which is what I did here. Then I added and subtracted c to the other side. So I got rid of this c here, so I added it to both sides there. Then I divided by a. If there was an a here, I need to divide by it. There wasn't any, so I didn't worry about it. Step 4 says take b over 2 squared and add it to both sides. So here's my b. I took it, divided it by 2, and squared it. And so I got 9, and so I added that 9 to both sides. Then factor. This will always factor when you do that. And so I factored into this statement. And then from there, you're able to solve it, which is why I'm able to take the square root to both sides. Then I added 3 to both sides, and I got this statement here. And now I can break it up if I wanted to, but that works. Next one, it says find the zeros of 2x squared minus 1 equals 3x. So I'm going to set the problem equal to 0. Well, to do that, I'm going to have to subtract 3x to both sides. And I wrote it in descending order. That's really important to do. Then I want to add and subtract c to the other side, so I'm going to add 1 to both sides. Then step 3, divide by a if you're able to. So I have an a here, so I have to divide everything by that a. So I'm going to get x squared minus 3 halves x equals 1/2. Then I want to take the b over 2 squared and add it to both sides. So I took negative 3 over 2, divided it by 2, so then these multiply together, so I get negative 3/4. Now if I square, I get 9 over 16. I need to take that 9 over 16 and I need to add it to both sides. Now a hint, this is so vague. How do I factor this? What the heck is going on here? And so a hint is the fact that it's going to factor into x and then whatever this number is. So in this case, it's x minus 3 squared equals, and then if I add these together, find the common denominator between 1/2 and 19 over 16, that turns into 25 over 16. But let's prove that. Notice I got negative 3. So I said x negative 3. So that's just kind of like a shortcut to kind of help us with that. So now solving this, now I can take the square root to both sides, and which means that this square and this are going to cancel out. And so now I'm going to get x minus 3 over 4. And that's going to equal plus or minus 5 over 4 because the square root of 5 or 25 is 5 and the square root of 16 is going to give me 4. And so now I can add 3/4 to both sides. And so I'm going to get x equals 5 over 4 plus 3 over 4, which is 8 over 4, which is 2. And then I also get negative 5 over 4 plus 3 over 4. That's going to give me negative 2 over 4, which is going to be negative 1/2. And so my solution is going to be 2 and negative 1/2. Now using the quadratic formula, once again we want to set it equal to 0, and so that's why I subtracted 7 on both sides. Now one thing that we can do is we could use the quadratic formula to be able to solve this. Now the way we do this is we have to identify what my a, b, and c are. And so my a is here, my b is here, my c is here. And so now that I have those values, you literally just plug them into the quadratic formula. So negative b, which is 2, plus or minus the square root of b squared, which was 2 squared, minus 4 times a, which is 3, times c, which is negative 7, over 2 times a. The rest is all simplifying. So to simplify this, I multiplied negative 4 times 3 times negative 7. That gives me the 84. Now I can add those together and I get square root of 88. Now I got to simplify the square root of 88. That turns into square root of 4 and square root of 22, which is the same as 2 root 22. And now that there's a 2 in common with all three of these terms, I factored out the 2, so the 2's are going to cancel out. And so that's why there's no more 2 here, and so it's just going to be negative 1 plus or minus root 22 over 3, and you could break it apart if you wanted to. For next one with the quadratic formula, identifying a, b, and c, my a is 1, my b is 5, my c is 8. Then you just plug them in. Once they're plugged in, it's all simplifying. So this right here is negative 32, this is going to be 25, and then 25 minus 32 is negative 7. Well, that's going to be an imaginary value, so I'm going to say root 7i. And so that could be a good answer, or if you wanted to break it up, you can break it up as well. So that would, both of those would be okay answers for now. Once we start talking about complex numbers more, I'm going to enforce this a little bit more, but just remember that all complex numbers are in the form a plus bi, a plus bi, a plus bi. So they always have to be in the a plus bi form. The last thing we're going to talk about here is the discriminant. Now the discriminant allows us to find the number of solutions and type without solving. So it gives us information about what kind of solutions I may or may not get when it comes to my quadratic equation. The actual discriminant is b squared minus 4ac. It's only this portion of my quadratic formula. Now even thinking about it logically, if this became 0, in my quadratic formula, then I'm adding and subtracting 0, which means this is just one value. If I add 0 to it or subtract 0 to it, I get one actual number. If this number is positive, then I'm going to be adding a positive number and subtracting a positive number from it. So b plus 1, b minus 1, those are two different numbers, so I'm going to get two different real solutions. Now if this value inside of my square root, if this is negative, well that's going to give me imaginary. So I'm going to be adding an imaginary and subtracting an imaginary, which is going to give me two different imaginary solutions. And so the discriminant, we're not looking for what the value is, but we interpret what the value is going to be from the information. So on this one here, if I find the discriminant, this is my b, this is my a, this is my c. So b squared minus 4ac, I get negative 7. Well, because this is negative 7, I know then it's negative, and so I know that I'm going to have two different imaginary solutions in complex conjugates. If you guys have any other questions, please leave them in the comments.